in retail, there is a lot of hope, and the silent revolution happens right now because the new generation of the image models powered by Stable Diffusion, Dream Booth, and many other kind of open source articles is transforming the way how retailers can now generate the product information, product images. So we are using already kind of large language models to generate product descriptions, product SEO metadata for the retail products. But we also are able to train the models to understand the specific products of a particular retailer, and then using prompts to be to place this product in a specific environment as merchandisers find fit. So, for example, like here we trained the model on a modest data set of 18 images or 30 images for the sweater and dress, and then we are able to provide the lifestyle images in a different environments with different kind of people, with different body types, which promotes inclusion and helps customers to visualize the products in a different environments in different ways. But the real holy grail of this kind of experience is virtual try-on. So this is something when you can use your own image and apply the customer product to the image in a very natural way and see how it will fit you. And this was attempted over last decade using all possible kinds of technologies. It was attempted using 3D modeling. It was attempted using virtual reality, AR, VR. Nothing really worked. So like there were smart mirrors, there were many different projects. We participated in some of those projects. Again, the technology was not quite there. So right now there is a new hope because the image generative models are extremely powerful and can be trained on a relatively small number of images. And then it can provide pretty convincing results. So what you see on the screen is kind of real life images from one of our projects with one of the fashion customers which we have, which helps to kind of generate those kind of images. It can be embedded in mobile applications, can be embedded into all kinds of user experience. So this is the general overview of the kinds of use cases, again, which we see right now in the industry, which we are working on. Not complete, but this is what we selected for this presentation. And let me turn it back to Ilya.
Yep, thank you. So now let me summarize basically like the general findings on these use cases and what we see in how companies are approaching like prioritization, and also provide some recommendations from our side based on our experience with different challenges and complexities. So basically, what we like the methodology for developing the general the generative AI roadmap from our perspective is as follows. We would generally recommend to initially to focus on the use cases that have more like technical use cases that have relatively low risks and implementation complexities. And in this diagram, if we map like these different use cases that we previously talked about in this value complexity axis, then basically these examples that are shown in green on the left-hand side are probably the good starting points in most cases. These are essentially like technical use cases that are focused on data pre-processing, for example, doing different transformation with products data, extracting structured data from unstructured sources, doing better data querying, like querying structural data like databases using natural language that Eugene just talked about. It can be like also different types of analysis of user-generated content, like this virtual focus groups, and so on. So these use cases, like in our experience, they are relatively easy to implement, and they are associated with relatively small risks. So we would consider to we would recommend to focus on these use cases as like initial ones and analyze if there are any like applications, any feasibility for these use cases in your organization, and it can create some foundation for broader GenAI adoption. Also, I would like to call out that we see like a lot of potential in AI assisted software development, basically using different tools for software development. Like in a broad sense, it can be coding, it can be development of deployment scripts, like DevOps type of applications. It can be documentation writing, and a number of other use cases. We're actually preparing the white paper specifically on this topic with some hands-on measurements. And we generally recommend to start adoption of GenAI tools in like IT and software development processes, because there are really like a lot of value in it, and the complexity of adoption is relatively low as well. Then like the second aspect of building these roadmaps is that for most of these use cases, it can be like a roadmap for of its own on how you start with initial prototyping and then expand it into like broader solution with high complexity and high value. And this is shown in these like nested rectangles for data querying example. For instance, you can start with like implementing this user-generated content analytics prototype, like this virtual focus groups. And initially, it can be like a standalone application that can be used just to prove the idea and demonstrate it to business users, align with them on the value of this use case, and so on. After that, this prototype most likely will need to be integrated with the marketing technology ecosystem, because like marketing users, they will not just do this basic analysis in this prototype. They will need to generate some actionable segments out of it. They will need to generate these messages, upload these messages, and different tools like email automation software and so on. And after that, potentially, this solution can evolve into some sort of a platform for like next generation marketing analytics as well. And at each of these stages, basically, you can increase the value, and complexity also increases. So typically, it's important to think about these solutions, about these prototypes, not as like standalone models, but to think about it in the long run, and how like longer term strategy about building these applications around these models, and different organizational changes that will be needed will be implemented as well. Now, if we talk about like more complex use cases that can require custom LLMs or involve some high-risk applications, for example, like legal contract reviews or legal contract generation, or use cases that involve like org changes or significant changes in user experience, then basically in this area, like use cases like knowledge assistance, virtual try-on, legacy migration, they in our view belong to this area, because it's like in our experience, it's actually not easy to implement these solutions. For example, to achieve good user experience with knowledge assistance, it's it's not sufficient just to plug in, let's say, a model and feed it with some data. There are a lot of challenges in practice if we're talking about building complex customer-facing applications. And even use cases like legacy migration that might appear straightforward in the beginning, actually in practice they are not that easy, or at least it's not easy to get really like significant productivity improvements. It might require to create custom tools and build relatively complex applications. But in general, from the value perspective, we recommend to focus on essentially three types of scenarios. First one is employee productivity improvements, when we build in use cases that improve or automate certain processes like data analytics or data transformations. Then the second category are use cases related to user experience improvements, like virtual try-on or customer-facing chatbots. And The third category are different internal tools that help in IT operations or other domains, for example, AI-assisted software development. So this is basically a high-level overview of how we generally recommend to approach use case prioritization and roadmap development. In practice, we actually maintain larger lists of specific use cases and use them as starting points for doing actual assessments. Finally, the last part. In the last part, I would like to talk about some challenges that we see with like executing these generative AI projects, and the way how we would visualize that is basically it's a number of like barriers or a number of different types of challenges that one needs to walk through to achieve final results. So first of all, we see a lot of challenges related to a business perspective on generative AI, because generally there are very inflated expectations that not necessarily match the true value of these use cases. And for example, like a lot of conversations about generative AI, they're focused on building essentially conversational interfaces, chatbots, but as we discussed, it's not the only area. There are a number of other more technical areas that also greatly benefit from generative AI, and sometimes it's not transparent from different types of assessments and conversations about generative AI that these areas exist. Then there are a lot of confusion and about capabilities of generative AI, for example, how well generative AI can work for use cases like virtual try-on, and it partly created by hand-picked results in different articles and publications, and in many cases we believe that vendors actually artificially create this confusion and trying to inflate this expectations or create an impression that generative AI works well for use cases where it actually doesn't. And it creates generally challenges with like use case prioritization, and we believe that this prioritization can be done well, mostly based on like first-hand experience, or at least some like prototyping of these use cases. Then the second category of challenges are related to technology. So assuming that you successfully passed this, navigated through these business challenges. The second like tier of challenges that you usually would face are related to technology, because in technology, like currently LLMs are like very powerful, but at the same time they have very significant limitations as well. And as you know, there are of course challenges related to grounding of the results, hallucinations of LLMs. There are different ways how you can work around it, but it of course improves the complexity of the solution. There are challenges related to predictability and testability of the solution and model upgrades, because most of the like public services, they kind of black boxes, and vendors are doing different changes, they're releasing upgrades, and it creates challenges related to how these updates can be tested, how you can make sure that the applications that you build actually like still working. And for LLMs, it's particularly challenging because in many use cases there is no like one single true answer. Basically, the generation can be done in different ways, produce different results. And although there exists some methodologies for assessing the quality of the results, in principle, it's a quite a hard problem of how you continuously track the quality of the results and make sure that there are no issues, especially in customer-facing use cases. And of course, there are a number of technical challenges related to development of custom models, challenges related to computational resources, and building the entire ML platform, establishing ML ops operations for this type of use cases. Then, assuming that, let's say you build a prototype that solves these technology challenges successfully, you typically would need to solve security challenges related to data privacy, data ownership, and establishing different guardrails around LLMs. Of course, it depends on the use case, but in many use cases that involve sensitive data or customer data, this will be required, or even like medical data in, let's say, some healthcare or pharmaceutical applications. And then finally, the last tier of challenges will be related to productization, how you navigate through limitations of compute. Resources or cost of compute resources, how you build complex applications that combine LLMs with different applications on top of them, and how you scale the solution in terms of number of users, either internally within the enterprise or in terms of external users. So this is kind of an overview of how we would recommend to approach basically like triage of these challenges and incorporating these challenges into the roadmaps. And in the last slide, we just wanted to provide a kind of like closer look specifically at the data privacy and security challenges. Just as an illustrative example, we of course will not go into like all the technical details, but to give you some idea, for example, how like complex privacy topics can look like. We put here a summary on different techniques that can be used for solving privacy challenges and privacy issues. So first, on the left-hand side, there are like a number of things that can be done in terms of building different wrappers and guardrails on top of public LLM services. Actually, there exist currently some libraries that implement some of these capabilities, but generally one needs to think about building additional like layers that automatically anonymize and de-anonymize data that are passed to public LLM services that scans input prompts with a goal to detect some like different types of attacks, like prompt injection or jailbreak injection. It's basically similar, conceptually, some of these attacks are similar to, traditional like SQL injection issues and so on. And then outputs produced by the LLMs also should be scanned with a goal to detect like malicious URLs or like toxicity of the responses and so on. So there is like a large whole area around how to build these wrappers on top of LLMs, even public services, to detect and prevent different types of issues. Then there are a number of techniques for keeping data privacy, which can be applied both for public services, like some of them can be applied both for public services, like anonymization and de-anonymization of input and output data. And there are techniques that can be applied for fine-tuning or building private LLMs, like differential privacy or federated learning. And many of these techniques actually are very new, like some of these papers on federated learning, for example, they were published just a few months ago, and people are still trying to figure out how it can be like industrialized and applied in real settings. And finally, if in applications that privacy is concerned, you generally would need to closely consider the trade-off between using public LLMs and private LLMs. There are a lot of considerations, of course, related to complexity of implementation, infrastructure cost, scalability, and so on. At this point, we generally recommend using like private LLMs for some specific technical tasks, like detection and removal of PII data, basically data anonymization. And then on top of this sanitized data, public services like OpenAI or GCP can be used.